So we're going to do one last problem involving this tangent plane and normal line. So let's look at the following problem. I want you to find a set of parametric equations for the tangent line to the curve of intersection of the ellipsoid x squared plus 2y squared plus 2z squared equals 20, and the paraboloid x squared plus y squared plus z equals 4 at the point 0, 1, 3. So one thing I would recommend doing is looking and graphing these two surfaces in some sort of 3D grapher, just so you can see how these two objects intersect. They're going to intersect in a curve, and this point that I'm given here is one point on that intersection curve. So what we're going to do is we have two surfaces here, and what we're going to do is we're going to find the gradients to both surfaces at this point 0, 1, 3. So we're going to take our ellipsoid, and again you need to move your constant over. You need to have 0 on one side of your equation. So x squared plus 2y squared plus 2z squared minus 20. And we're going to take our paraboloid. We'll call that function g. So if I move the 4 over, it'll be x squared plus y squared plus z minus 4. And we're going to start by finding the gradients of these. So the gradient of f, take the derivative with respect to x, 2xi, plus the derivative with respect to y, 4yj. The derivative with respect to z is 4zk. Take the gradient over here for our paraboloid. So if it helps, maybe I'll draw a line here so we don't mix up the two. The derivative with respect to x, 2xi. The derivative with respect to y, 2yj. The derivative with respect to z is just 1, so it'll just be k there. And now you're going to plug in your point, which was this 0, 1, 3, into these. So the gradient of f at 0, 1, 3 will be 4j plus 12k. And the gradient for the paraboloid at our point will be 2j plus k. And now what I'm going to do is I'm going to take the cross product, because remember the cross product of these two gradients is a vector that is tangent, where you can think of normal being here, is tangent to both surfaces at the point 0, 1, 3. So we're going to take the cross product of these two vectors. So the cross product of f at 0, 1, the gradient there, and the gradient of g. So remember how we do the cross product. I, j, k, 0, 4, 12, 0, 2, 1. If you compute this cross product, you're going to get negative 20i. So this is going to give us a direction for our line. And so remember, directions, the direction vector of a line, it's not unique. And so in particular, what I see is that this only involves I. So what this means is this vector, it's going to be parallel to the x-axis. And so for my line that I'm looking for, I've got the point 0, 1, 3. Got the point, and then my direction vector, well, I can just take the vector 1, 0, 0. You could take this negative 20i as well if you want. And then you're going to write down the parametric equations for this point, or for this line. It'd be x equals t plus 0, y equals 0t plus 1, and z would be 0t plus 3. So if you simplify these down, it'd just be x equals t, y equals 1, and z equals 3. And those would be my parametric equations. Remember, when you're writing down parametric equations, your answer is not unique.